We were just trying to find the Y-Intercept when the last video ended, and of course I didn't see it end, so I'm talking to myself some more. But anyhow, I'll explain what I did while you weren't listening. So Y-intercept, x equals 0, just like above. So I went up to my function, and everywhere I saw an x, I plugged in 0. So f of 0 equals 0 squared minus 2 times 0 minus 8. And 0 minus 8 is negative 8. So that means the y-intercept is 0, negative 8. And then as I was talking to all my imaginary friends, I put 0, negative 8 here. Then I plotted 0, negative 8. And then I reflected it. This was 1 left of the line, so then I made a point 1 right of the line. Let's go ahead and label the vertex, and then go ahead and draw your parabola. Make sure you don't make it V-shaped. It should be U-shaped. And now we're ready for the last two questions, domain and range. So domain goes left forever and right forever, just like every other vertical parabola. So it's negative infinity to positive infinity. My dog's in here. Sorry, she snorts a lot. Polly, shh. Okay, to get the the range, we do bottom to top. So what's the lowest y value? Right there, negative 9, and it's an actual point, so we make it a bracket. And it goes up to infinity, the arrows. And now you know why I'm such a nitpicker about parentheses, is because that's what's going to help us with infinities on domain and range. And remember, order matters, so the smallest x should be listed first, which goes left forever, so the smallest x is negative infinity, and the largest x is positive infinity. The smallest y is negative 9, the largest y is infinity. So always make sure your order is correct and the shapes of your parentheses and brackets. Okay, let's switch over to our back page. We're almost there. I'm going to let my dog out of the office so you guys don't get submitted to the torture I have every day. Come on, Polly. Okay, so this was the last thing we learned were the inequalities. And first thing we have to do, remember, is find the boundary points, which are the solutions. So we're solving a quadratic, and we have tons of ways to solve quadratics now. We have factoring, which is usually what I always do first. Try it. And we have quadratic formula and completing the square. But let's try factoring. So does everybody recognize this as AC method? Because there's a number in front. So factors of 6, that's subtract a 5. Oh, so it is factorable. So as long as it's factorable, I would use factoring first, because we should be the best at factoring since we've been doing that the longest. So factors of 6, read the problem backwards, that's subtract a 5, 6 and 1. This says the signs will be different. And this says make sure the larger number is positive. So 1 is negative, 6 is positive, and you can always test it if you're not sure it's right. 6 minus 1, yep, that's 5. Okay, so we're ready to replace this with those two values. So now we have 2x squared minus 1x plus 6x minus 3, and we're finding the boundary points or the solutions, so we set it equal to 0 for now. Later on, we'll come back to that. Actually, let's take a look at it right now. This is less than 0, so we're looking for the part of the graph. Less than means below the x-axis. So we're looking for the parts of the graph that when we graph it are below the x-axis. And we're going to be using parentheses. So that's another thing you could make note of ahead of time just to keep you on the right track when you get to the end. And the reason we're using parentheses, oops, I kind of wrote on that, sorry, is because there's no equal sign. When there's an equal sign, we use a bracket. When there's no equal sign, we use parentheses. Okay, so we got that straight. So let's go back to this. So we need to do grouping after we do AC. And 6x minus 1x is 5x, so we haven't made an illegal substitution. This equation's still equivalent to our original. So now we're ready to do GCF 3 times. So the first time is for these two. X is common, so take an x out of each term and you're left with 2x minus 1. Then we always bring down that sign. The GCF for these two is 3. When I take a 3 out of each one, I get 2x minus 1. Ding, ding, ding. This is what I like. So whenever the parentheses match, that means you're going on the right track. So now we have a third GCF, which is this common binomial 2x minus 1. So I take the 2x minus 1 out of each, and that leaves me with x plus 3. And then if A times B equals 0, man, you had the zero factor property like a million times. Either A is 0 or B is 0. So we get 1/2 for our first one. 2x equals 1. X is 1/2. And on this one, we get x equals -3. So we draw our number line. And remember, the points do have to be in order. And we plot our bounding points. So -3 is the smallest, so it goes on the left. 1/2 is the largest, it goes on the right. So you can either do test points like we did at the end, on one of the problems in the notes in 7-6, or you can say, oh, I know how to draw a parabola. I know what it looks like. And this is a parabola because it's second degree. So you could sketch your own little parabola in there. And let's see. So we have, I'm going to make this smaller so I don't have to keep going up and down here again. So we have parentheses, we have below. So remember that means we keep these open since they're going to be parentheses. That's because there's no equal sign there. And the parabola cups up. So we can sketch a little rough picture of the parabola. It's going to look something like that. And we want to know, when is the parabola less than 0 means it's below. Just think less than 0 is below sea level. So we want to know what x values go with the part of the graph below the x-axis. Well, you can see it's from this x to this x, and they're open circles, so we use parentheses, -3, 1/2. And remember, that is not a point. Those are not solutions. That's the interval where this graph is below the x-axis. So every x you put in between -3 and 1/2 will give you a negative number because negative is below. So -2.9 is a solution, -2.999, -2, 0, 1/4. They're all solutions because this is the interval where the x's are yield negative y values, or they have y values that are below the x-axis. Okay, so that is the parabolic inequality. I mean, these are both called polynomial inequalities, but this one was a parabola. Now this one is not a parabola, and since we don't know what cubics look like yet, you learn about them in the next class. This is the one where we have to do the plus minus thing. So 4 terms right away. Well, let's first talk about this. So that says greater than or equal to. So this is above or on the x-axis. So above is for the greater than. The equal means it could be on. So above or on. But that also tells us this problem's going to use brackets. So get all your notes there, and then you're ready. So I'm going to keep this one big for a little bit until we get to the bottom. So now we have to look at the problem and go, how do I find the solutions? Oh, 4 terms. There's only one way to factor 4 terms, and it's called grouping. So group these two, group these two. I'm going to use a different color. So my GCF for the first two would be x squared. So I take an x squared out. I divide both of these by x squared. And I get x plus 1. Anything divided by itself, remember, is 1. Here's the tricky part. Don't get fooled here. This one has a negative GCF because we learned in chapter 4, if the leading coefficient's negative, you pull out a negative GCF. And it looks like negative 9. So now the trick is to remember you're dividing both of those by negative 9. So negative 9 divided by negative 9 is 1x, or just x. Negative 9 divided by negative 9, positive 1. And we look and go, yay, our parentheses match, so we're on the right track. So we pull out that common binomial, x plus 1. And then we write what's left in the second parentheses, which would be x squared minus 9. And just like the video that we did of this in 7-6, that should make you think here. What is that? A difference of squares. So this one factors again, because aren't we going to have 3 solutions? Yep. So x plus 1, x plus 3, x minus 3. And if a times b times c equals 0, then either a is 0, or b is 0, or c is 0. So solve all of these by doing the opposite. And it looks like we're going to get negative 1, negative 3, and positive 3. And so now we have 3 boundary points. And remember, this one we have to do the test point method that we demonstrated in our 7-6 notes. So negative 3 is the smallest. It goes on the left. Negative 1 is the next smallest. And then 3 is the largest. So if we knew what a cube looked like, we could draw it and do the whole thing here, but we haven't learned what that looks like yet. So what we're going to do right now is pick test points. So we need some number to the left of negative 3. Well, I try to make it as little as possible, so how about negative 4? Then we need some number in between negative 1 and negative 3. Well, negative 2 sounds like a good one. And here is where 0 lies, so let's be sure and pick 0. And then a number bigger than 3, we could pick 4. So we have to do 4 test points to see if it's positive or negative. And remember, because none of these are copies of each other, we don't have any double roots. Once we find one, let's say this one's plus, we know it's going to go plus, minus, plus, minus. If this one's minus, it's going to go minus, plus, minus, plus. So they alternate as long as they don't have any double roots, which this one doesn't. That means the same number twice. So let's do a couple and then we can just finish the pattern after we do a couple, but we are running out of time, so I'll pick up on this on the next video, okay?